All right, hello and welcome back. So we are now just going to talk about what margin of error is and do a little example with that. And then we will do a confidence interval example kind of from start to finish. And so margin of error, it's not a hard definition at all. It's just our z star times our standard error. And so remember, this is our kind of confidence interval formula. And so in general, it's what we are adding and subtracting to our point estimate. Remember, our point estimate is just a fancy word for our kind of best guess based on our sample data. And so in proportion land where we've been, that is just p hat. Okay, and so this example kind of deals with a poll from an article that says that Biden drew support from 49% of likely state voters and 45% backed Trump. That 4-point gap is within the poll's margin of error. And so when you read about kind of polling data, articles will often use this term margin of error. They'll say something's within the poll's margin of error, or they'll say something is outside of the poll's margin of error. So take a second to pause the video and just kind of think about what that means. So you don't have to write anything down. Just kind of think about what they mean when they say that this 4-point gap is within the poll's margin of error. Okay, so what they really mean is just that the margin of error on the poll was more than 4%. More kind of less formally, we could think about the difference between Biden and Trump. If it's within the margin of error, that difference could be due to random chance. And so based on this poll, we really can't say who's doing better because the difference is within the margin of error. And so that means that Biden might have just polled a little bit higher than Trump on this case, just on random chance. If the poll had said that, or if the article had said that the 4-point gap was outside the poll's margin of error, then we would say, okay, it's outside this margin of error, and so it would be less than 4%. And then we could say, okay, well, the difference, Biden looks like he's doing polling higher than Trump is, at least according to this poll. All right. And so now we're just going to go through an applied example from start to finish. And so now that we know what confidence means, we know that if we're 99% confident, for example, then that if we repeatedly sampled our population over and over again, then 99% of the intervals that we constructed would actually contain the proportion that we're interested in. So that's all going on in the background now. And we're just now just checking the assumptions for the interval, doing the calculation, and making an interpretation. And so we're going to find the proportion of all SLU students, or try to find the proportion of all SLU students who have a Twitter account. And to do so, we've gathered data from the Stat 113 survey at the beginning of the semester. Based on that survey, out of 192 students. So that's our sample size. 115 have a Twitter. And so our p hat is just 115 divided by 192, which turns out to be 0.599. And so now we can check if it's valid to use the normal distribution to construct our confidence interval with like the z star stuff. If you kind of recall, our check was this success-failure condition. And so we want to check if n times p hat is bigger than 10. And so 192 times 115 over 192, 115. So that kind of checks out. We also wanted to check if n times 1 minus p hat is bigger than 10. And so that's 192 times 77 over 192, and that's 77, so that holds as well. So our success-failure condition holds. If you remember, our exact condition was actually n times p and n times 1 minus p, but we don't know what the proportion is. So that's what we're trying to figure out. Since we don't know what p is, we're just putting in our best guess, which is p hat. We're also just going to make a note that independence holds. Again, that's the assumption that we also have, but we haven't really talked about yet, just because we don't want to kind of bite off too much at once. And so we will talk about this assumption later. And so now it's kind of the easy part, the calculation part. So we know we want a 95% confidence interval. And so we have our formula. We know that our standard error for p hat is this thing, which we didn't derive because this isn't theoretical stats, but we saw in StatKey that it matches up with the standard error of the sampling distribution that we had built up. And from here, this is what I think most people think is the easy part, because you just have to plug in all of the numbers that we have from up here. If you multiply all this out, you should get that. And then our interval is usually reported with an open parentheses, lower bound, comma, upper bound. And so this lower bound is found when you would subtract 0.069 from 0.59, and then this upper bound you would get from adding the two together. Okay. So the last step that we're going to use, and so just to kind of outline these steps, by the way, because we'll be using them a lot, prepare, check, calculate, conclude. That'll be our framework for pretty much every confidence interval and any hypothesis test that we do from here on out. The conclude is usually, or it's always an interpretation. And so we're going to use kind of the usual somewhat formal interpretation, which is the most common, and say that we are 95% confident. So kind of we know what this means, that if we were to sample students over and over millions of times, calculate a confidence interval for each sample, then 95% of them would contain the actual proportion of students who own a Twitter account. We don't know what that proportion is because we only have our single sample. That the proportion of all SLU students with a Twitter is between 0.5297 and 0.6683. These are just the bounds of our interval. All right, so we've got a tiny bit to kind of finish up in our next video, just talking about the type of sample we got and how that might affect any sort of conclusions that we can make. But as always, let me know if you have any questions, and yeah, hope you have a great afternoon.